The next generation science standards are very much SWH based. It's all about critical thinking, making models, debating our ideas, coming up with claims and evidence. It's built into the next generation science standards. So people are seeing, oh my gosh, this fits together beautifully and provides this structure, because it does provide somewhat of a structure for teachers to enable kids to be able to do these science concepts of the next generation science standards in a very inquiry-based, science process practices type of way. So I think that next generation science standards are going to lead to better classroom instruction based more on an approach such as a SWH. A great barrier for science teachers is when they're given a science textbook, because it's so easy to teach from a textbook. There's not really a lot of planning involved. The investigations are built in, what the kids need to know supposedly is built in, so you just turn the page. And kids weren't interested in that. There was the novelty of getting your first science textbook that was fun, and then they looked forward to the recipe-like days just so they weren't reading. But 90% of the classroom was spent reading from a textbook that some publisher had decided what you needed to know about that topic. So actually the science textbook would drive the instruction and what happened in a classroom, and therefore limited any really cognitive interactions of the student other than regurgitation of what the textbook wanted you to know. It wasn't hard, and teachers, I think, were instinctively knowing that kids weren't being as successful as they wanted in those critical thinking skills, in the problem solving skills. Lots of complaints that they couldn't get kids to think, that they didn't want, the kids didn't want to do it. They weren't handing in assignments, lack of motivation, lack of interest. So I think instinctively they're like, there's got to be something better. It is different than what is being done or has been done in their classrooms. The first thing is that we talk about science topics in a conceptual way. So instead of we're going to study rocks, it may be the Earth has many materials that help us to understand how it changes. And systems are always looking a way to balance those bigger concepts. So that was a big change. And then helping kids articulate what they already knew about those things. Because we live in our natural and design worlds, we already know about everything we learn about in science. We know something. There's some concept or piece of the concept that we have something to stick all of our new learning to. So it's a challenge to get kids to articulate that, because they'll tell you, I don't know anything. I don't know anything. And we had that happen. So one of the pieces is to find out what they know, and they say, I don't know anything. And then we'd say, so what questions do you have? And they generate 100. Just by being able to generate those questions, it tells us they know a lot. They already know things about this. Now, what level do they know about, and where do we need to get them at this age? What's developmentally appropriate for them to understand whatever grade that they are in at this time? That's the challenge for teachers then. So how do I get them from where they're at to my desired state of where they need to be? And how do I get them there in a way that's student-centered? But those questions then can help us lead them down that path. So if we present it in a conceptual way, there's no right path to get there. They can take many different paths to get there. But we do help them, coach them to which of these questions will help us get there efficiently, which of these questions will help us learn about the concept more deeply. And kids are okay with that. Help me craft my question so it makes more sense. That's okay. And they'll learn to do that more and more on their own as they see which questions for them have been more successful. Doing an experiment. There's lots of ways to get there, and we would want them to have varied ways. Will we build a model? Will we interview? There's a multitude of ways, and then to think, okay, so how am I going to support kids in those ways so that they're successful in finding out what their answers are? So through these investigations, they come up with their question, they collect data in some way, and then they analyze that data to come up with a claim to that question, and they use the data and their experiences to determine what evidence can I support that claim with. So we build confidence in their ideas, and they become more articulate about, this is why I think what I think. And therefore then can have fruitful, deep conversations with others, those professional conversations that we want as adults, they can have as children to debate, all right, I get that I might not have been right, or my evidence is weak, and I'm willing to change my ideas based on what I just heard you say. And can we come to a consensus about what we believe is the answer to the question, so that then we can consult scientific thinking to see how close or far we are? So always coming back to that bigger idea, always thinking about our own thinking towards those bigger ideas. And then we would have kids do a series of these questions, continue to reflect on how their learning is growing and changing, making it public, debating their ideas, reflecting on what scientists would say. And then at the end of a learning period, which we know is the reality in schools, we have 180 days to get this done, we would talk about, all right, now what do we know? So let's try to summarize that for a different audience. Let's communicate it and transform our learning so that someone else can understand how our learning has grown and changed and what they need to know about this concept. Why would anyone care? And for that, it's very transformative for kids. It's like people would care about what I just learned. It's not about just getting a grade on a test, because it's not. That, I think, is the biggest shift. Science is not supposed to be about being successful on your report card. It's supposed to be about learning about your natural and designed world. So that's what we want for kids, and I think more and more teachers want that for their kids too. I think for a lot of kids right now, science classes they feel that it's giving the teacher what they want to hear, or proving to the teacher that now they know what's inside their head, the teacher's head. And they don't feel like it's about them, and they don't feel like it's purposeful to them, that it's just I will complete this science so that I can move on to the next science class or move on to the next requirement. And for some teachers, that's not good enough. That they not only do kids build their confidence in what they know, but what their ideas are, but they're excited. The kids are excited, and they'll ask, when are we going to learn more about our big idea? When do we get to do science? You know, who do I get to talk to today? What do I get to learn today? Do we get to get into the books? I mean, they're ready and excited to learn. They're building confidence. They have problem-solving skills. They're becoming analytical. So when they read or see something on TV, they can be critical consumers. So it builds a science literacy that textbooks can't. They just can't, because if you are an author of a textbook, it's about your ideas. And as hard as we try to craft a textbook to drive instruction, there's no way to make it as interactive as a human brain. So I think teachers, once they get past the discomfort of how different this is, they see that evidence from kids, and it's motivating for them as well, and they enjoy their profession more. As part of the approach, I said before that there's a question that they have generated. They come up with a claim and evidence. So then what happens is we debate that claim and evidence with others in an applied way, where we're debating ideas and not people, and we support students in how do we craft that kind of language where you're debating ideas and not people. How do we be analytical and critical of the information without being mean? And I think that by doing that, kids can then transfer that to other places. So they're bombarded by TV and Netflix and even games that are set in science kind of settings. So they don't just take what they hear, because that's not how it's done in the classroom. You don't just accept the first thing you hear, because we're valuing the debate. We're valuing being open to alternative ideas, and we're valuing that you as a human being will decide whether or not those ideas make sense to you. And when given new information from a reliable source or an unreliable source, do you believe it? And why do you believe it? And can you support why you believe it? And how does it match or not match what you thought you believed? So I think by building those skills, students just will start using them. And they do. We see it. They start using it. They do it in math. They do it in reading. They do it within the school day. But you asked about parents. That's what they'll say. It's like they take this home. So what we tell teachers is just to try it. Just try it. Try a piece of it. Post the big idea in your classroom. Allow kids 10 minutes just to sit and talk about what do you think that big idea means. Or have kids generate questions. Whether you decide which of the questions you're going to use or you let them, just at least allow them to ask the questions. Turn to your neighbor and talk about what I just said. Just starting small with those good instructional practices that we know research has told us make a difference for kids. It doesn't have to be the whole approach day one. But I think the more they try those smaller pieces of the approach, then they're more willing to try more pieces until their day is through the SWH approach. Through this approach, we are very much respectful of students' ideas. So we have to teach teachers, you have to be patient because many of their ideas are not going to be scientifically accurate for many days. I mean, they have to have multiple chances or opportunities to negotiate how their learning is changing and growing, and that's going to be uncomfortable, and they're going to go home and they're going to tell parents inaccurate things. And I think that is almost an ego issue for us as educators and adults. Like, what do we do if they go home and say something that's wrong? Well, you have to educate your parents to know that this is a journey and learning doesn't take place overnight or we'd all be awesome golfers. We've got to be patient with this learning. So I think that the more respectful we are of that learning and respecting kids' ability to articulate what they think even when that thinking is inaccurate, and just being, what do we think about that idea? That is something I've never heard about before, and I am intrigued. So say more, tell us more, and let's write it down if that's okay with you. And we're going to see, are we going to continue to this idea? Right now, none of us can refute it. So let's see what happens. So I think that gives everyone permission to share. And I think in a traditional classroom, unless you know what the teacher is thinking, I wouldn't put it out there. Nobody wants to feel like they're dumb, but everybody wants to feel like they're valued. And if you have a voice, you're valued. That is what's most important in this classroom, is revealing what we know. And celebrating what we know is going to grow and change. We really don't want to be at the same place in 8 weeks. So it's a celebration, and everybody wants to be a part of a party, right? The whole approach is based around language. So we will write a lot, and we will write personally. Just, everybody write in your journal what you think right now. Now let's turn to our partner and talk about what you just wrote. And then maybe in the middle, how do you think your ideas have changed? Now go back to your journal writing and scribble some things out, or add a few words, or add on to the bottom. We write as a class, so we might do a concept map as a class, and we record our thoughts publicly as a class. Or we might work in small groups and report it on chart paper, or in a group journal. I mean, we're constantly negotiating our understanding privately by giving you think time, with a partner by giving us talk time or partner writing time, as small groups, as whole classes. So by allowing us to think in our heads and think on paper and talk about things, it's that constant negotiation of ideas and developing this understanding of a concept rather than a topic, and being very metacognitive. How is our thinking changing? That, I think, is the only way to truly help kids understand concepts forever. These are enduring understandings that we don't want kids to forget it because we just took the test and we're done. We want them to take this for a lifetime. So if you want it to be a lifetime, we've got to be very, very specific about what is it that we want for a lifetime. Those enduring understandings, and that's why our big ideas are conceptual in nature, because it's not about the factoids. We have Google for that. It's really about this lifelong learning. I've been very happy to see more kids having the confidence to go into science careers and study science. But personally, I'm more excited about kids that are able to be good science consumers as citizens. because in that aspect, we're hitting every single child. I want every single child to have confidence in what they're learning and saying and giving opinions on. And I want them to be willing to change their ideas. So that would be my hope, that this process teaches them how to be learners of their world. And whether that's in science or history or psychology or mathematics, it doesn't matter. I want them to be learners and to be good citizens and productive people because they had this experience in science. That's a hard transition to value and respect kids' ideas when we were taught that we were the holders of the information and they needed to learn what we think we know. So that's a big barrier. That's hard. Yeah. It's easier said than done. What we consider evidence of learning, that's another barrier of this, because that kind of evidence, can you go out in the world and make good decisions, is very different than taking an end of unit test. So what we consider learning has to change from multiple choice and traditional evaluative procedures, because we've got to be evaluating, are their ideas changing? Do they have strong evidence? Are they able to articulate their ideas? Do they grow and learn? Have they shown evidence of a deeper understanding around these concepts? Can they apply this to new situations and real world examples? Those are the kinds of things. And it is harder to evaluate, but it's necessary because our goals are so much bigger than did you learn these 50 facts.